Now when I put this into a word problem, the floor at an international double squash court is rectangular with an area of 25a squared minus b squared feet. What is the length and width of the floor? Well, if the area is this, then if I factor it, I'm going to get the two dimensions. I'm going to get 5a plus b is one side, and 5a minus b is going to be the other side. The perimeter of the floor is 140 feet. Determine the length and width of the floor if the length is 1.8 times the width. So the length is longer than the width, so I'm going to assume this is my length and this is my width. I know that a perimeter is the same as 2 lengths plus 2 widths, which means that 140 is going to equal 2 times 5a plus b and 2 times 5a minus b. 140 is equal to 10 a's plus 2 b's plus 10 a's minus 2 b's. And when I combine the like terms, the 10a and the 10a are going to give me 20 a's, and the positive 2b and negative 2b are actually going to cancel each other out, which means that I know right away that I have an equation in one term. If 140 is equal to 20a and I divide both sides by 20, then 7 is going to be equal to a. So I figured out what one of the variables is, but I don't know what my b is yet. The second part was that determine the length and the width if the length is 1.8 times the width. Well, if the length, which we already said up top here, is 5a plus b, is the same as 1.8 times the width, which was 5a minus b. The other nice thing is we know what a is now. We know that it's going to be 5 times 7 plus b, and 1.8 times 5 times 7 minus b. And so when I'm doing this, I can say that I have 35 plus b is equal to 1.8 times 35, or 63, minus 1.8 b's. I'm going to move the b's to the one side, so I'm going to add 1.8 to both sides. And I'm going to subtract 35 from each side, so that I have all the b's on one side, I have all the constants on the other. If 2.8b is equal to 63 minus 35, which is 28, then when I divide both sides by 2.8, b is equal to 10. Now I have enough information to solve what they are. Now I know what a is, I know what b is, so I can say that the length is equal to 5 times 7 plus 10, or 45. And in this case, it's in feet. I know the width is equal to 5 times 7 minus 10, or 25 feet. Now, we need to remember the first step of factoring is we should always be checking for a common factor every single time. So, in these cases, I'm going to pull out a common factor because this is not a perfect square and this is not a perfect square. But when I pull out a common factor of 2, I'm left with a squared minus 25, and now they are a difference of squares. And I can say that's going to be 2 and a plus 5 and a minus 5. For example B, I can pull out a common factor of 3. I'm left with x squared minus 4y. Those are both perfect squares, so I can say that's going to be 3 and the square root is going to be x. Square root of this is minus 2y. Actually, let's do plus first, and x minus 2y. For example C, they are perfect squares, but it's still much easier to do with smaller numbers. So I'm going to factor them down to start. I'm going to divide both parts by 4, and I'm going to get 4 and 36 p squared q squared minus 1. And I'm going to have 4 and 6 pq plus 1 and 6 pq minus 1. And in the last case, I can divide both parts by 3 and by x. And I'm left with x squared minus 9, which is going to give me 3x and x plus 3, x minus 3. And that's it.